Okay, so lesson 7.2 is looking at multiplying and dividing rational expressions. So we were already introduced to this idea a little bit when we talked about equivalent rational expressions in the previous lesson. So we're not stretching too far from the norm when we talk about multiplying rational expressions. So key things we need to look for, well, first thing is that when we multiply any sort of fraction, it's top times top, numerator times numerator, then denominator times denominator. The same rule applies here. Same as with fractions. Okay, so in addition to completing the mathematical part though, as I talked about yesterday, you want to state all your non-permissible values. Now, I recommend doing this before you do any multiplication, before you do any simplification. Always look for your non-permissible values. If we don't remember what those are, it's that our denominator can't be 0. So in this case, my non-permissible values, well, it's constant in the denominator here, but I do have a variable in my denominator in the second rational expression. So 2c cannot be equal to 0, so c cannot be equal to 0. So that's my non-permissible value. Beyond that, I can multiply. Now, yesterday I mentioned that we can cancel out diagonally before we even multiply. So I'm going to be working with that concept. Please feel free, if you don't quite spot how that works, to continue multiplying directly and then looking to reduce. So in this case, I see 2 and 2 are in the numerator and denominator, so they turn into 1 and 1. Anything divided by itself is 1. But 5 and 10 actually also have a common multiple or a common factor. So 5 goes into 5 once, 5 goes into 10 twice. By simplifying this here, now I've got my kind of lowest or most reduced fractions. And when I go to multiply, it's going to be a little bit easier. So 1 times 1 is 1. So I'm just left with d in the numerator. And I've got 2 times 1, which is 2, and I'm left with c here. And so that would be my answer with my non-permissible value. Same thing happens here. I'm going to look for anything I can simplify. So x and x would cancel out because they're multiplying and dividing. 2 goes into 4 evenly. And so we get 2 and a 1 remaining here. 3's can't go into 5s. There's nothing common there. I don't have any matching binomials anywhere. So that's all I can do for simplifying. So we've got 2 times 5 is 10. And then x plus 3 times x minus 1 all over 3 times x plus 1. And the reason that this is my final answer is that I've simplified and then I've accounted for everything multiplying together, 2 times 5 and then so forth. You can also expand these, so we're left with 10 x squared minus 2x minus 3 over 3x plus 3, which can then simplify or expand even further to 10x squared minus 20x minus 3, all divided by 3x plus 3. So that would be my solution. Now, what did I forget to do? My non-permissible values. So I'm going to do them now. But I'm going to go back to that original question before I did any canceling. So I'm going to erase that so I can see everything. So in this case, I've got 2 denominators with variables in them. So I know that 3x plus 1 cannot be 0. In this case, if I divide by 3, I get x plus 1 can't be 0. And so x cannot be negative 1. Now, if you spotted that immediately, you can just state that piece, go right ahead. If you don't spot it right away, that's okay. We have a way to solve for it. Our other denominator also has a variable in it. It cannot be 0 either, so x cannot be 0. So now we've got a couple more restrictions in relation to our answer. So this is great, but it can't be 0 or negative 1. Even though we can plug 0 in and it technically would work, that's only because it had canceled out while we were simplifying. Now our last example here is not in factored form. We want it in factored form so that we can spot any common factors between any of our polynomials. So I'm going to factor these out. Don't switch your variable. Minus 4, a plus 3 over, this is a difference of squares, so a plus 3, a minus 3, all multiplied by a minus 3, a minus 1 over, I can factor out a as a common factor of both of those terms, so I'm left with a minus 4 here. Now, because we're multiplying, it's just this times this times this times this. And this times this times this times this in the denominator, okay? Which is what allows me to look for canceling. So a minus 4 shows up in the numerator and the denominator, so I can cancel them out. A plus 3 shows up in the numerator and denominator, so they cancel out. A minus 3 also shows up in the numerator and denominator, so all I'm left with is actually these two pieces. So my simplest form is going to be a minus 1 over a. Now, unfortunately, again, I forgot to check my non-permissible values. It's always easier to do it when it's already factored, so I'm going to kind of go back and look at these guys. Oops. Which is why it's always better to kind of slow down and do those before you do any canceling. Don't do as I do, do as I say. Okay, so I've got this denominator can't be 0. Well, that means that a can't be positive or negative 3. Because if I plugged in negative 3, that would be 0. If I plug in positive 3, that would be 0. Again, you are still more than welcome to use this strategy of setting up your whole denominator equal to not being 0 and then solving from there. A can't be 0 itself if I plug it in that denominator, and it can't be positive 4 because that creates 0 within this bracket here. So I've got a lot of non-permissible values in this particular scenario. Okay. One thing I do want to draw your attention to is some people would look and say, okay, a squareds cancel, negative 4a's cancel. Unfortunately, we are not allowed to do that. Canceling is an operation that happens or is something that we can do when we have opposite operations. We're allowed to cancel out these terms here because essentially what we have is a minus 4 divided by a minus 4. And we know that that is equivalent to 1. So that is what allows us to cancel things out. But when we're dealing with a statement like this piece here, it's not just a squared divided by a squared. It's a squared minus 4a plus 3, that whole piece divided by this whole piece. So we can't cancel out individual terms. So do not do that. That is incorrect. Okay. Now, dividing rational expressions is very, very much the same. So we're still following our fraction rules. Okay, so we take the reciprocal of our denominator and we multiply instead. The only tricky part is that this whole piece is actually a denominator. So what that looks like is I could rewrite this as 5n to the 4 divided by 2 all over 5n squared over 6. So this whole piece here cannot be 0 because it's technically all denominator, which means that the numerator within that part can't be 0 and the denominator can't be 0 in that part. Another way of thinking about it is that I'm going to rewrite this as 5n to the 4 over negative 2, oops, I forgot the negative there, multiplied by 6 over 5n squared. So our numerator becomes our denominator. So when we have to take the reciprocal of that second fraction, we're actually creating a new denominator that we need to account for in our non-permissible values. So when I go to do my non-permissible values for this question, the first fraction is nice. There's no variable in the denominator, so there's no restrictions there. But originally it looks like we've got no non-permissible values in that second denominator. But because I take the reciprocal, now I do have a variable in my denominator. And so when I solve for my non-permissible values, I've got 5n squared cannot be 0. If I take the square root of that, I've got 5n cannot be 0, or n cannot be 0. Again, if you can spot this part right off the hop, good on you. Go nuts. Just jot it down. If you need to solve for it, take the time to do that. From here, I'm going to expand this because I want to get rid of all my brackets, just like my order of operations tells me to. And then I've got -2, and now this is going to be over 25 over n squared. Remember, if it's in brackets, that square applies to everything in there. Okay, now I can see, well, n squared and n to the 4 will simplify to be n squared in the numerator. 2 also goes into 6, so it'll be 1 and 3. Okay, so that'll be my simplified version if I do that in step 1. Actually, I can also do 5 goes into 25 5 times. So lots of simplifying here. Okay, so if we've got all of that, we've got 1n squared times 3 is 3n squared. We've got -1 times 5. So that's -5. You could rewrite this as -3n squared over 5. That is also totally acceptable. Both of those are good answers. Whether you like to have the negative out in front or in the denominator, that's up to you. That's how we do it. So make sure you do the non-permissible values for all denominators, including the reciprocal. So that's the one kind of thing we need to remember. Division becomes a little bit more tricky with. So in our case here, my non-permissible values become 3x can't be 0, so x can't be 0. That's one of them. Okay, did that one. Second denominator, x times x minus 2 can't be 0. So that means that x can't be 0 or 2. But when I go to rewrite this as a reciprocal, I've got 2 times x plus 1 over 3x multiplied by x times x minus 2 over 4x plus 1. Now I've got a new denominator that I also need to account for. So 4x plus 1 can't be equal to 0, so x cannot be -1. So I've got a lot of non-permissible values there. From here, again, I like to look for things to cancel immediately. So x squareds go, or x plus 1s go away. Individual x's that are multiplying can also cancel out. And 2 goes into 4 evenly, so that would become 1 and 2. We've got a common factor there. And so from here, I've got 1 times x minus 2, so it's just x minus 2, and then 3 times 2 is 6. So all these non-permissible values still apply, even though it looks like I don't have a variable in my denominator. All right, so C looks a little messy. Don't worry. The only thing that is different about this compared to the previous question is that you're going to need to factor. So I recommend pausing the video right now and practicing on those factoring skills. Okay, so you should have a factored form like this, noting that our first one was a difference of squares, and the second one, it actually had a common factor, which is always the first thing we should be looking for. From here, before I go any further, I'm actually going to follow my own advice and do my non-permissible values. Oh, no, that should be division. So first denominator, x cannot be 0 or positive 4. Second denominator says that it can't be negative 5 or positive 4 again. So notice I'm not rewriting it because it's already been accounted for. But when I need to do division, what I do is I take the reciprocal of my second function, or my second expression. So I've got x plus 4, x minus 4, multiplied by x plus 5, x minus 4, all over x plus 3, x minus 2. Well, when that's the case, now I've got two new sets. I've got a new denominator over here that I need to account for. So negative 3 and positive 2 are also non-permissible values. A whole lot of different values here. Now again, I look for cancellations whenever they're possible. Unfortunately, that is the only cancellation we have here. And so I'm not going to expand my final answer in this scenario because it's just going to be a little too messy. And we haven't really dealt with quartics or anything to any major extent. So I'm going to leave it as x plus 4, x minus or plus 5, x minus 4, all divided by x times x plus 3 times x minus 2. Okay, and so there we go. We've got our non-permissible values, and I've simplified my expression. If you want to stop now, go ahead. I will show you how to expand this, though. I'm going to pick out that these two are a perfect square, or a difference of squares. So I'm going to write x plus 5 times x squared minus 4. All divided by x times, and I already know this one because it was actually my original question, x squared plus x minus 6. From here, it's still two binomials, so it's still FOIL for the numerator. It's just simple distribution for this scenario, so it's really not that bad. And we get x cubed plus 5x squared minus 4x minus 20, all divided by x cubed plus x squared minus 6x. And that would be my final answer. Okay, still the same non-permissible values. So you've got some practice questions to do in your workbook. Definitely take an opportunity to do those, and then you'll be ready to move on to looking at adding and subtracting, which can be a little bit more complicated.